All right, example on page 195 of number 2 is asking us to find the value of C that will satisfy the conclusion of the mean value theorem. See that? For the function f of x equal to x squared on the interval from 0 to 2. So that's just, that is just the quadratic function defined from 0 to 2. All right, what are the prerequisites of the mean value theorem? First of all, it's continuous. Yes, you have a quadratic. And then that's obviously differentiable because the derivative is 2x, so there's no problem satisfying these two. Okay, so because the prerequisites of the mean value theorem are satisfied, then we can find a number C on the interior. Okay, but that means it's a number between 0 to 2 that will match the line secant to the curve at that maps, or that connects the y values from at 0 and at 2. Okay, here's what's going on. There's your 0, 0. There's your 2, 4, because when x is equal to 2, y is 4. So what is the slope of the secant line? In other words, let's look at the slope. We're looking at the slope of the yellow line. So how do you find the slope? Okay, so that's f of x is equal to x squared. So basically what we're going to do is f of b minus f of a, right? And then divided by b minus a. So in this particular case, f of 2 is 4, and then f of 0 is 0, divided by b minus a, 2 minus 0. Okay? Now, according to the theorem by the mean value theorem says is that we can find a number between 0 and 2 so that its derivative at that point will match this secant line. So that means, what do I put in here? That's the big question. What do I put in there? Okay, so what we put in there depends on what is f prime of x. F prime of x is equal to 2x. So all you have to do is just replace this x by c. So put 2c there and then solve for c. So in this case, what do we have? Let's go ahead and simplify that. That's 4 over 2 is equal to 2c. That means 2 is equal to 2c. Divide both sides by 2. We see that letter c is equal to 1. And that matches our graph. So this says that if I take the derivative of if I evaluate the derivative at c equal to 1, okay, then you see that's 2 times 1. That matches the slope of the secant line. And what is it? 4 minus 0 over 2 minus 0, which is 2. Do you see how they match up? Isn't that just the coolest thing? The slope of the red line is the same as the slope of the yellow, which is the secant line. So that means we were able to find the value c equal to 1 so that its derivative of the line tangent to that curve will be equal to the slope of the line secant to that same curve. They're parallel, so they have to have the same slope. A physical interpretation. Like I was saying a while ago, we can think of the number f of b minus f of a whole thing divided by b minus a as the average change of f over a b, the closed interval a b, and f prime of c is an instantaneous rate of change. Okay, so it's like it could be an instantaneous speed. Okay, then the mean value theorem says that at some interior point, the instantaneous change must equal the average over the entire interval. So you have a car accelerating from 0 to 8 seconds, right? And it traveled from 0 feet up to 352. Now what is the average? Well, you just take the average speed would be 352 minus 0, right? Divided by 8 minus 0. Okay, that's the average rate of change. Now that will be equal to 44 feet per second. The mean value theorem says that at some point during the acceleration, the speedometer should have read 44 feet per second. You can't read that, but you'll read 30 miles per hour. If you convert this, you'll get 30 miles per hour. See, so the average rate of change somehow at some point in between should match up with a certain value of at an instantaneous. At one point, your car should have a speedometer reading of 30 miles per hour. Exercise 4.2. Checking the mean value theorem. Find the value or values of C that satisfy the conclusion of the mean value theorem for the functions in the intervals that's specified, okay, going from 1 through 6, but I only cut and paste up to 1 through 5. All right, when you're given this kind of problem, the first thing you have to consider is whether the conditions of the mean value theorem are satisfied. First of all, is it continuous on the specified interval? And then, is it differentiable again on the specified interval? So let's just say we want to look at number 1, right? So number 1, is it continuous? Yes, because that's just a quadratic function. So we know that a quadratic, or a polynomial for that matter, a polynomial of degree 2 is a quadratic function. Okay, so it's continuous, and even more, it's differentiable on the interior 0 to 1. So when you say that's the case, then you'll know that it satisfies the mean value theorem. Then the conclusion says you'll be able to find a C, right, between where? 0 and 1, such that the derivative at some point between 0 and 1 will match the slope of the secant line, okay, that connects it when x is equal to 0 and when x is equal to 1. All right, so what do we do? What are the steps? We've already looked at this derivative, the conditions, so let's just take the first derivative. Number 1, f of x, let's just write it here, is equal to x squared plus 2x minus 1. Then you have the interval from 0 to 1. Like I said, we've satisfied that it's continuous and differentiable. And then on the interior, continuous on the closed interval. All right, so the first thing we'll have to do, okay, is evaluate at the endpoint. So f of 0 is equal to negative 1, right? Because that's just 0 plus 2 times 0 minus 1, so minus 1. Next is, what is f of 1? F of 1 would be 1 squared plus 2, that's 3, minus 1, so that's 2. Okay? And then next is we get the slope of the secant line. What is the slope of the secant line? So slope of the secant line would be 2 minus negative 1. That's your f of 1 minus f of 0. F of 1 minus f of 0 divided by 1 minus 0. And there you have it. That's equal to 3 over 1, which is 3. Okay? Then the next thing we'll do would be, let's take the derivative. F prime of x is equal to 2x plus 2. Okay, now substitute, replace this by a c, and set it equal to the slope of the secant line. Alright, So let's do that. So substitute. So we're going to solve now what? Now instead of the c, we write it as, instead of the x, we write it as c. So 2c plus 2 equal to 3. All right? And then you just solve. So there you're going to get minus 2 minus 2. So you'll have 2c is equal to 1, and therefore c is equal to 1/2. Now, what does this say? That means I got a value between 0 and 1. Sure enough, 1/2 belongs to the, is between 0 and 1, so that its derivative at 1/2 will match 3. Is that the case? Yes, because when we take the derivative here, 2 times 1/2 is 1 plus 2. It's equal to 3. So you see it matches. All right? Okay, how do we graph that? When x is equal to 0, f of 0 is -1. When x is equal to 1, y is 2. So maybe let's say here is 2. All right? So that's saying that somewhere in between 0 and 1, there is a point where the slope of the line's tangent to the curve. So it's right here. This line is going to be parallel to this slope of this line that connects. Okay, so the slope here will match this one. The slope here would match this whole thing. Okay?